Okay, so rational equations, we'll have two parts, part 1 and part 2 for lesson 7 and lesson 8. First of all, a rational equation is an equation that contains a rational expression. So it means that I have to have a variable in the denominator of one of my terms. So when we go to solve rational equations, we can solve rational equations graphically or algebraically. We'll look at the graphically method first. So graphically, you can solve in two methods. There's the intersection method, and then there's the y-intercept method, or the zero method. So if I was to do the intersection method, that's the first one. If I have the equation 3 over x plus 1 plus 1 over x minus 1 equals 2, what I would do is I'd let y1 be equal to the left-hand side of the equation, and y2 would be equal to the right-hand side of the equation. And then I need an appropriate window setting. So the window setting is given to you. So if we grab our calculators and we put this in, what we need to be aware of is we need to make sure that we put this in properly. So this becomes 3 divided by x plus 1, and it has to be all one unit. So what I need to do is I need to open up a set of brackets first. 3 divided by, and then I open up another set of brackets, and then I can put in my x plus 1, and then I close the set twice. So that makes the 3 over x plus 1 has one whole unit, but separates the x plus 1 as being the denominator. So that's the reason for the second set of brackets. Plus, and then I open up another set of brackets, 1 divided by, and then bracket x minus 1. And then I close the bracket twice. If I do not put brackets around the 3 and around the 1, what will end up happening is order of operations, it'll mess things up. You're better off just keeping your brackets in place. And then I'd let y2 equal 2. Change my window setting to be from -5 to +5, going up by 1s. And I can do that for both the x and the y's. And then I would graph. So the first graph is my rational expressions graph, which looks really weird. And then my second graph is my y equals 2. And what I have here is 2 points of intersection. So I want to determine what the y value is with those points of intersection. So some of you, when you graph that, your graph gave you a straight line here and here. That's not really part of the graph. It is, but it isn't, and we'll talk about that in a couple of minutes. Okay? So don't worry about those 2 straight lines that get drawn in. Okay? So what I want you to do is I want you to find these 2 points of intersection, and I'm going to show you the easiest way to do that. When I go in and I find my intersect, if you notice, I'm not sure where your cursor jumped to the first time. Did it jump to this spot? Okay, so if I go to find this one, I just press enter until I get intersection. And I get that x equals 0. So that's one of my possible solutions, is that x equals 0. So I've got this equation that went like this. This is where x equals 2. And then I had the equation, or the graph went like this. Was it quite that? No, not that far over, sorry. And then I had this. And then I have this part. And as some of you noticed, you said that you've got these lines. I'm going to put them in as a dotted line that come in like this on the graph. So I found one of my intersection points. Then when I go to find the other intersection point, so second calc, choose number 5. If I start to move the left cursor, I'm going to have to wait for this cursor to fall down, and it's going to kind of disappear, and then it's going to jump up to the other side. It's kind of time consuming. If I could just be on this line here, I could get over to that intersection point. And I can jump to that if I use the arrow up and down. If you notice right now, y1 I have as being my first equation. If I press the down button, it jumps to y2. And now I'm on that second line, and I can cursor over to the intersection point faster. So then I press enter, and I get that x could equal 2. So what this means is that if I put 0 into the graph, I will get 3 over 0 plus 1 over 1. Or sorry, not 3 over 0. 3 over 1 plus 1 over negative 1. So I'll get 3 plus negative 1, which will equal 2. If I put 2 into that graph, I get 3 over 3, which equals 1. And then 1 over 1. So I end up getting my 2 again. 1 plus 1 equals 2. The next method is the x-intercept method. With the x-intercept method, that means putting everything over onto one side of the graph. So I subtract both sides by 2. So this right here should say graph y1 as being 3 over x plus 1 plus 1 over x minus 1 minus 2. So if we put that into the calculator, I can scroll over to the very end and then just put minus 2 and clear what y2 is. And then I get a different looking graph, still has some similarities. For some of you, it's still going to draw in these straight lines. Where do these straight lines come in at? What x value do they cross the axis at? Rachel, you got a straight line, right?
Yeah, I'm just putting it back in my calculator though, because
Okay. Evan, did you get one of those straight lines?
Yeah, it looks like -1 and 1.
Negative 1 and 1. And then I've got a graph that kind of goes like this. Another part that goes like this. And then a part in the middle. So this time the feature that I'm using on the graph is the 0 feature to find the x-intercepts. So second calc, and it's choice number 2. And then that's where I get my left bound, right bound. So I have to be on the left side of the 0 and then the right side of the 0. And what I get here is my calculator, just because of like some of the settings and the fine tuning, gives me 3.48 e to the negative 14. That's a really, 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 really small number, because that's 14 zeros and then the, 13 zeros and then the 3. So we could say that this number here in effect is 0. And then I can go find my second 0. So I wait for the cursor to come in on the other side. I need to be on the left side of the 0 and then on the right side of the 0. And I get the same solution, x equals 0 and x equals 2. What I would like you to do to start off with is I would like you to do question 1C. Solving rational equations algebraically take more work because it's algebraically. How you want to solve rational equations algebraically, you want to get rid of the denominator. So getting rid of the denominator would mean multiplying everything by a common denominator. It's multiplying all the tops by the common denominator because then that'll eliminate my denominators as I go through. So we're going to kind of skip the instructions. We're going to jump straight into the example and then I'll go back through the instructions afterwards. So if I look at class example number 1, I have 4 over 1 and a 7 over 1, and then 2 over x and 3 over x. So what is my common denominator for 1 and x? X. So I'm going to multiply everything by x. So if I multiply everything by x, I'm going to get 4 times x, which is 4x. If I were to multiply the second expression by x, I would get 2x over x. And what happens to my x's? They're going to cancel out, which will leave me with 2. And then on the other side, I get 7 times x, which would be 7x. And then when I take the 3 over x and multiply it by x, the x's are going to cancel again, and I'll be left with 3. So now I have an equation where I no longer have denominators. What's my non-permissible value in my original equation? What can't x equal? 0. So let's put that in here just in case. So now I go through and I start solving this. I want all the x's on one side and all of the numbers on the other side. So what should I move, the 4x or the 7x? 4x. So that'll leave me with 3x. Then what would I move? Would I subtract 2 or subtract 3? Oh. And what is 2 minus 3? -1, and then divide by 3. And I get that x equals -1/3. Now I need to verify this. So verifying it means I put it back into the original equation. So when I go to verify, I have 4 plus 2 over 1/3 on the left-hand side, and then I will have 7 plus 3 over 1/3 on the right-hand side. So what is 2 divided by 1/3? Remember, divide fractions, multiply by the reciprocal. So what's the reciprocal of 1/3? 3. So what's 2 times 3? What's 4 plus 6? Okay. So then on this side, oh, this should be a -1/3, shouldn't it? Yeah. So that should be 4 plus a -6, right? What's 4 minus 6? -2. Okay? And then when I go 3 divided by -1/3. So in other words, 3 times -3. So then what's 7 minus 9? -2. So I've shown that the answer works in the equation. I've verified it. So now if we go back and we look at our strategies. If the equation consists of a single rational expression on each side, you could use cross multiplication to simplify it. That's example B. There's only one term on each side of the equation. I can cross multiply. If it has more than one term on each side, that's class example A, then what I would do is I would multiply the term in the equation by the lowest common multiple of the denominators. And then from there, what you should hopefully get is either a linear or a quadratic equation, which you then solve using all of the methods that you knew from before. And number 4 is the important one. Always be aware that there are domain restrictions when you're dealing with these rational equations. Check your solutions accordingly. Verify the solutions. Note that the solution cannot be a non-permissible value. So in other words, in A, because x can't be equal to 0, if that had been my answer, we would state that there's no solution. So if we look at B, in a sense, the solution or the way that we go about solving B is no different than how we solved A. We're still multiplying by what my common denominator is. My common denominator is x plus 1 times x plus 2. So if I was to think of multiplying this whole thing by an x plus 1 and an x plus 2, when I go to multiply the expression on the left-hand side, the x plus 1 on the bottom would cancel the x plus 1 out on the top, which would leave me with 5 times x plus 2. Because what I would have, if I wrote this all out, is this. This is what I would have when I multiplied 5 over x plus 1 by this expression. X plus 1's cancel, there's my 5 times x plus 2. When I do the same thing on the other side, the x plus 2's cancel, leaving me with the x plus 1. And then when I take a look at this, it is the cross multiplying. So I want you to see why the cross multiplying works. Because when I use my common multiple of the denominators, I'm canceling out the two denominators. What are my non-permissible values? What can't x equal? -1 and -2. Okay, so how would I solve this equation now? What should I do?
I would expand it, so multiply x plus 2.
Okay. So expand by removing the brackets. Then what would I do?
Move 2x to the other side.
Okay, so what's 5x minus 2x?
3x.
And let's move the 10 to the other side at the same time. Then we can save ourselves a step. So if I move the 10 to this side, it'll become negative. What's 2 minus 10? And then divide by 3. And I get -8/3. Which is allowed in this step here. It's not equal to -1, it's not equal to -2. And now I need to verify. So I have 5 over -8/3 plus 1. How many thirds are in 1? 3. So I'm going to change my 1 to a 3/3. And then I'm going to have 2 over -8/3. How many thirds are in 2? 6. So I'm going to have 5 divided by, because that's what that division bar means, -8/3 plus 3/3. -5/3. And to divide, I multiply by the reciprocal. So what's 5 times -3/5? Which would equal? -3. And if I think of my denominators and my numerators, denominator and numerator would cancel each other out. Okay, so if we look at the other one, I have 2 divided by, what is negative 8/3 minus, or sorry, negative 8/3 plus 6/3? Negative 2/3. So then multiply by the reciprocal and I get 2 times negative 3/2, which would equal, which is negative 3. So the two sides equal each other. We verified the equation. We have come up with the correct solution. So the next 3 examples, just repeat the process. We just make the questions a little bit more challenging. So in class example 2A, I have 1 term on each side of the equation. When you only have 1 term on each side of the equation, cross multiply. So 4x minus 2 times 3x plus 5 equals 6x minus 1 times 2x plus 3. And in this expression, or in this equation, what can't x equal? And negative 3/2. Okay. So now if I go to remove the brackets, 4x times 3x, 12x squared, and then I've got a 20x and a negative 6x, which would give me 14x and minus 10. So expand the right-hand side and tell me what you get. So what did you get?
12x squared plus 16x minus 3.
What can you tell me about the 12x squareds? They're going to cancel each other out. So then I want x's on one side and the numbers on the other. So which one would I move? The 14x or the 16x? So 16x minus 14x would give me, and then this negative 3 I'd add. So negative 10 plus 3. Negative 7. And then divide by 2. And I get negative 7/2. So when I go to verify this, 4 times negative 7/2 minus 2. So it's 4 times negative 7/2. And negative 14 minus 2 is negative 16. Okay, let's do the denominator. 2 times negative 7/2 plus 3. So what's 2 times negative 7/2? Negative 7. And what's negative 7 plus 3? Negative 4. So what's negative 16 divided by negative 4? 4. Okay? So that's one side. Now I have to do the same thing to the other side. 6 times negative 7/2. So the easiest way to multiply this through, the 6 is a numerator and the 2 is a denominator. 6 divided by 2 is 3, and 3 times negative 7? Negative 21 minus 2. Or sorry, that shouldn't be 2, that should be a 1. So negative 21 minus 1. Negative 22. Okay? negative 7/2, which is going to give me negative 21/2, which doesn't reduce down, plus 5. So I'm going to change that 5 to 10/2. And then I'm going to ask you, what is negative 21/2 plus 10/2 equal? Negative 11/2. And then this would be multiplying by the reciprocal. So I'd have 2 over 11 that I'd be multiplying the negative 22 by. The 22 and the 11 would cancel each other out, leaving me with a 2. Times 2 would give me my positive 4. And that's without using a calculator. With B, can I use the cross-multiplying method? No, because I have more than one term. I have 2 terms on the left-hand side. So I have to multiply by, in essence, I call it multiplying by the common denominator. What would be my common denominator for this equation? So t plus 1 and t minus 3. So when I go to multiply this 5t minus 2 over this t plus 1, by my common denominator, the t plus 1s would cancel out, which would leave me with the 5t minus 2 times the t minus 3. And then when I go to multiply the second expression, or the second term, by my common multiple, the t minus 3's cancel out. So I'd multiply the t minus 1 by t plus 1. And then on the right-hand side, the denominator for 3 is 1, so nothing cancels out. So I get a 3t plus 1 and t minus 3. So I'm going to give you a moment, and I want you to expand all of that out, removing the brackets and simplifying it. Okay, so if we start removing the brackets, with the first expression, I would get 5t squared minus 17t plus 6 minus 2t squared plus t minus 1 equals 3 times t squared minus 2t minus 3. Is that what you got for the first line? So then if I collect my like terms, 5t squared minus 2t squared would be 3t squared. Negative 17 minus 1 would be negative 18t. And 6 minus a negative 1 would become 7. And then on the other side, I would have 3t squared minus 6t plus, or sorry, minus 9.
Whoa.
Do we agree so far? So then the 3t squareds are going to cancel each other out. I'm going to move the negative 18 to this side to make it positive. So I get a positive 18 plus negative 6 would give me 12t. Bring the 9 over so it becomes positive, and I would get 16. So then my final answer would be 16 over 12, which I can divide by 4 to give me 4/3. First thing that I should check is 4/3 one of my non-permissible values? So I go back to the top, and identify what can't t equal. -1 and +3. So it's not either of those. So now I can verify. So I have 5 times 4/3 minus 2 over 4/3 plus 1. So I may want to use my calculator to help me with this. 5 bracket 4/3 bracket minus 2. Calculator is going to give me a decimal answer. I'm going to change it into a fraction. What do I get when I change it into the fraction? And then 4/3 plus 1 would be 7/3. And then I'll do the same thing with the 2t. Minus 2 times 4/3 minus 1 over 4/3 minus 3. So the 2 times 4/3 minus 1 would equal what'd you get, Allison? 5/3. And then 4/3 minus 3 would equal -5/3. So 14/3 divided by 7/3. Remember I told you last week, if the denominators are actually the same, I can divide the numerators. 14 divided by 7, 2. Denominators are the same, divide the numerators. 5 divided by -5. -1. And what's 2 minus -1? 3. And that equals the right-hand side. Okay, the last question makes you think everything is going good, and then we throw a wrench into things. Where's the wrench? When you look at the denominators, what do you notice? There's a difference of squares. I have a denominator that can be factored. Factor it first. We're going to write it as x plus 4 times x minus 4. How this helps us is when we go to multiply this by our common multiple. What's the common multiple for the denominator? X plus 4 and x minus 4. If we had not factored out that difference of squares, the most common mistake that would have been made is we would have thrown in the x squared minus 16, which is repetitive. So we want to factor denominators whenever possible. So the x minus 4's cancel out. I get 1 times x plus 4. In the second one, I get 2 times x minus 4. And on the right-hand side, the entire denominator cancels out that multiple, leaving me with just 5. So x plus 4 plus 2x minus 8 equals 5. 3x minus 4 equals 5. What do I do with the negative 4? And when I move it to the other side, what do I get? 5 plus 4. Now what?
Divide both sides by 3.
And what does x equal? And what are my non-permissibles? What can't x equal? Positive and negative 4. So it's not one of my non-permissibles. Now I go through and I double check. 1 over 3 minus 4 plus 2 over 3 plus 4 has to equal 5 over x squared, so 3 squared minus 16. What's 3 minus 4? Negative 1. So 1 over negative 1 would just be negative 1. Plus 2 sevenths. How many sevenths in 1? 7. So negative 7 over 7 plus 2 over 7. How many sevenths? Negative 5. 3 squared? 9. What's 9 minus 16? Negative 7. Do the two sides match up? Yes, they do. Okay, so your questions. 2A, 3B, and 4 to 7.